We are going to use the analysis of variance test, also called ANOVA. It is an extension of the t-test for the significance of the difference between two sample means, except that ANOVA is used with independent variables with more than two categories and with interval ratio dependent variables.
We will use the shortened version of the 2009 General Social Survey to conduct a one-way analysis of variance test, because we are investigating the effect of a single variable on another. In this test, our null hypothesis is that at a 95% confidence level, there is no difference between number of activities taken in a month and annual income. Our research hypothesis is that there is a difference. The first step is to download the General Social Survey into SPSS.
If you have a variable with smaller categories, you may need to recode the variable in order to create more equal sample sizes. Healy and Proust use the example of provinces, which they collapse into regions in order to create more equal sample sizes. For our variable, this step is not necessary.
Once the dataset is downloaded into SPSS, click Analyze. Scroll down to Compare Means and select the One-Way ANOVA option. In the One-Way ANOVA window, find the variable average number of evening activities respondent goes out for in a month. Click the arrow button to move it into the dependent list.
Next, find annual personal income of the respondent and move it into the factor box using the bottom arrow. Click Options on the right-hand side and click Off Descriptive in the Statistics section. This will produce a summary of means and standard deviation along with a summary of analysis of variance. Click Continue and then OK. The following output will be produced.
From a sample of 1,388 respondents, the mean number of activities taken in a month is 26.44, with a standard deviation of 17.118. The results indicate that the number of activities is distributed differently across income levels.
There is no need to look up the F ratio in the F table when the exact probability is provided. Because the sig value 0.001 is lower than 0.05, the indicator of significance, we reject the null hypothesis. So we can conclude that at the population level, there is a significant difference between number of activities that people take in a month between income levels.
It is important to note that one of the major limitations of ANOVA is that it does not tell us which groups differ significantly from each other. However, we can use an error bar graph to get an indication of which pairs of means are significantly different.
To create an error bar graph of the 95% confidence interval for each mean, select Graphs, Legacy Dialogues, and then Error Bar. Click Define. In the Define Simple Error Box dialog, transfer the dependent variable activities into variables and independent variable income into the category box axis. Click OK. The mean for each income level is presented by the open circle. The bar itself represents the 95% confidence level. By eyeing the overlap of the confidence interval, you can get a sense of which means are significantly different.
From the error bar and the descriptives table, people with income levels less than $9,999 have a higher mean activity level than the rest of the population. However, mean activity level peaks again at $20,000 to $29,999, and then again at $80,000 to $99,999. From this, it looks like a trimodal distribution.
Tamara now knows that there is a difference between income levels and number of activities taken in a month. However, ANOVA doesn't tell her exactly which income levels are significantly different. She has a decision to make.
This type of statistical analysis can be used by different companies and websites, for example dating websites, to tailor their product or service to attract particular users.